Alright, I just saved this out on the P drive. So I've created very quickly, very simply, a little timeline. So we're right here right now. Alright. And I'll even put here /lab. No, that's not even right. So what we did last week was we went over chapters 1 through 8 in the book. Today we're going to go over chapters 9 through 11. What we don't finish today, if there is anything, we'll finish Wednesday, and Wednesday you'll see examples. Alright? On Wednesday, too, I will give you, it'll be either 3 or 4 programs to do, and a couple of them are not going to be easy. It's not a threat, but I'm just telling you. And then next week we don't have class on Monday, so you'll have lab Wednesday and the following Monday and Wednesday. So you look at it this way. I don't know if I'm going to give you 3 or 4 or 5. I don't know. But let's say it's 3. Then you can kind of dedicate a class period to each program. The first program won't be very hard. The second one will be harder, and the third one will be harder still. All right? Then the next week, so we're talking now, what is it, like 3 weeks from now? 1, 2, 3, no, yeah, 3 weeks from now. We'll be done with the book by the end of the week. All right? Because I'm going to go over chapters 12 through 19, but I'm not going to give you any homework on that. Then I'll add to this, and I'll try to rough it out for the Objective C timeline too. All right? Since that's such a different language, we're going to be doing some real simplistic stuff, and then it'll get a little harder. Then we'll do a program where we'll build, like I told you, we'll build that simple game as a class. All right? Yeah. Whatever animation that we do, at least at first, is going to be simplistic. All right? All right. So I'm up to page 235, and that's the beginning of the pointers chapter, chapter 11. Now, again, as we go through this, just to show you something really quickly, okay? Again, I'm going to write just a really very simple little program here. So if I come through here and I do this, let's say, and again, I'm making this up. It's meant to be purposely, unbelievably simple, okay? All right. So I'm going to come in here and let's just pretend I did the pound include stdio.h, everything else. And like I said, this is just going to be simple. So again, I'm doing this right literally off the top of my head. Int main void. All right. Void. All right. So I'm coming in here, and in my main, I'm going to declare 3 variables. Int x equals 6. Int y equals 7. Int z, you've seen this kind of thing before, equals add 2, and pass in there x and y. Okay? You've seen this kind of program before, so I'll put my prototype up here because I should, even though it's an integer. Add 2, int x, int y. All right, so there's my prototype. And I guess if I do want to be complete here, I can pound include stdio.h. All right. Now, I'm going to come down here and write this function because you're used to this. So int add 2, int x, let's call them something else, int n1, int n2, return n1 plus n2. Okay? I think you'd all agree you've all seen stuff like this, right? Okay? So literally, if I print off something that looks like this, so if I say printf %d plus %d equals %d backslash n, and I say x, y, z. Would you all agree looking at this? This is just going to say 6 plus 7 equals 13. Everybody agree with that? It's not meant to confuse you or anything. I mean, that's the way it would work. What do you think would happen if I did this? Everybody see that? What do you think would print out right here? That's correct. So inside of here, since I'm passing these variables, it's passing in a copy. But I'm changing the copies. So it's going to add 71 and 29, which will give me 100, and it'll return 100 and it'll stuff it into Z, which is a little bit warped math because now it'll say 6 plus 7 equals 100, which is a little scary and a little weird, right? All right. Let's say that for whatever reason I want to be able to let you change the number. Now, you with me? I want you to be able to. But if you change them, I want all of them to reflect the actual change. Does that make sense? Then I could do this. And I'd have to change that up here. So for lack of better words, when you start seeing asterisks and ampersand, start thinking permanence. Because what we looked at first, the first example I gave you, we were changing copies. That's why it came back, and as Kelly said, it was going to come back and say 6 plus 7 equal 100, which is just really weird. But it's because we were working with copies. We weren't making a permanent change. If we run this one, now we're permanently changing N1 and N2. And remember, N1 and N2 are just our names for X and Y. So now it's going to come back and say 71 plus 29 equals 100. Does that make sense? But when we're passing this now in here, what that's doing is it says, don't pass a copy. I don't want a copy, so don't pass this and don't pass this. That's not what this is saying. This is saying pass the address of where that lives and the address of where that lives. So kind of, if that confuses you, imagine it was this way. Let's say that you're the city assessor. And among other things, if you want to, if you don't like the fact that I live here at 6004 South County Road G, and Mark lives right next to me, but that's 6100, and so it's really pretty far away. And you're the county assessor, and you come in and you go, you know what, that's a dumb address. If he's 6004, that should be 6010, something like that. So you can permanently change the address. What we're doing here is we're not permanently changing the address, but we're permanently changing the contents of what are in that address. And again, if it still confuses, you look at it this way. All right? And I probably have given you this example before in other classes. If Black Hawk moves out of here tomorrow, true or false, the address of this place doesn't change. No, if Black Hawk moves out of here tomorrow, is this building still going to be housed at 6004 South County Road G? So the contents could change. So if we leave, and let's say they decide they're going to move Beloit Turner in here. Don't ask me why, but let's just pretend they do. All right? Then Beloit Turner would live here, so the contents would be different. That's what we're doing here. We're telling you to go out to that address and change its contents. The reason that that's important is just like Java, one thing about C is, here's a hint, how many things can you return maximum from any function? One. How many are we returning here? Technically none, but one. We're returning, I should say one, because that's this one. But we're permanently changing those two, here and here, which are really those two, which are here and here. Does that make sense? So if you want the ability to change more than one thing and return more than one thing, permanently change it inside of a function, that's one of the biggest uses for pointers there is. Does the concept make sense? There's other reasons that you use it also. And I want to mention one more thing to you, because I don't know why, but Quotient I don't think mentions this in the chapter. If you see it, let me know. All right? So, if I come through here and say this, if you use %p, it's designed to print out a memory address. So if I want to literally know in memory where X and where Y and where Z lives, that's how I can do it. So this will say X lives at, it'll give me some weird address. 3581746, something like that. All right? And there's no guarantee if I run the program again, I'm going to have the exact same memory address. But it's where that memory address of X or Y or Z live during this run of the program. Does that make sense? Because I believe he doesn't even mention %p in here, and I don't know why he doesn't. I didn't write the book. But I'm just trying to throw a few things at you before we really get into this in any depth and breadth of coverage. All right, yes. Yes. This isn't an alias. This is like saying, this is the same thing as saying, Black Hawk Technical College lives at 6004 South County Road G. All right? Zane lives at 11 Main Street type of thing. That's exactly what it's saying. All right, so keep that in mind as we start going through this. All right? Because this is what sets C apart from other languages, is the fact that you can work with pointers, and it uses a concept that's referred to as indirection. And in some ways, I've already mentioned what indirection was to you. Now look at the example that they give in here. It's kind of a weird example, but it works. It's the thing that's right here. It says, okay, let's use me in here. Okay, we need to get a new printer cartridge in here. Okay, and the company we work for, really, it's Joe in IT. So what I have to do is send an email. I have to send an electronic help ticket, and then I usually just copy it to Joe, and then Joe comes down here and changes it. Actually, he checks first because they're so sophisticated now with those toner cartridges that if it says anything, if it gets to 10%, he gets sent a signal, but he gets to send another signal when it's like less than 1%. That's when he comes down here and changes it. All right? It's not just this room, it's the whole school. And everybody says, oh, times are tough. No, it's because people are so frigging cheap. All right? So, it says that same kind of thing. So when I want something done, I don't do it. I delegate somebody else. That's sort of the idea behind a pointer. It says it applies to the same way pointer works. And a pointer implies an indirect means of accessing a value of a particular data item. So the example they give, you're going to say it's not what you did. I know that. I showed you one usage. So in other words, if I'm writing main, let's go back to where we had main here. All right? So if for some reason, the examples he gives, the reason I showed you what I did is I'm going to show you now what he did. Okay? So he did something like this. Int X pointer. All right? I'll make sure I'm showing it the same way he did. Let's see. Int star X pointer equals ampersand X. And I said X here, but I had my hand on the wrong key. Now, if I use this, you asked before, Zane, you were talking about an alias. That and these are the same thing now. So now if I wanted to, rather anywhere I'm saying X over here, I could say star X pointer. Now, normally when you do that, I don't see an advantage of doing this. He's making an alias, but he's using it in the same function he's in. I don't understand why he's showing you that. I'm showing it because he did, and I don't want you to go back and read the chapter. Well, you didn't talk about any of this stuff. No, I'm talking about the stuff I think matters. And why he did this, I don't know. There's nothing wrong with it, but I don't know why he did it. All right. So when he talks about a pointer, again, the pointer is pointing to the address. That's what he's getting to. All right. So again, I'm not saying, are my examples better than his or whatever. It doesn't matter. But notice what he's showing you here. All right. Int count equal 10, X. All right. Int X pointer. All right. And now he's got here, basically what he's saying is now whether you use X, which he's going to set the 10 in here someplace, all right, or you end up using count, they're both, and I don't know, he's using this as a pointer here so he can, instead of just saying int count equal 10 and then saying int X equal count, he's doing it, but he's doing it using the addresses instead of the physical values. All right. And then he does, it must be a really good idea because he does it again on the next page. He says you can do it with any kind of variable. What I'm showing you is the way that I think that it's used most often, what I showed you. The ability to go and change the value of more than one variable inside of a function and have it permanently be changed. All right. One thing to realize is you can have pointers to anything. So that's an example of a pointer to a character. Before I showed you a pointer to an integer. You can point to anything, including structures, arrays, functions. All right. And again, I go back to what Kelly had mentioned when we talked last week about having working at an installation where there was a program that called a program that called a program. You can do that kind of thing with pointers. All right? And it can call a function in a program that calls a function in another program that calls a function in another program. You can do it any way you want to. Now, when you start working with some of this stuff, you end up getting some really weird looking syntax. See that right there? That's a pointer to a structure that you're trying to reference. And see up here? I'm asking you, try not to read this if you can, but see this up here? And then see when you're using it down here? See how it's in parentheses, but it's not in parentheses up above? Why do you think that is? One word. The word is precedence. If you leave it off, it tries to do date pointer dot day and then take the address of that. So you need the parentheses to make sure you're doing it in the right order. That gets so confusing that most people don't write it like this. When they've got pointers to structures, they write it like this. That's another operator in here. It's a minus sign followed by a greater than sign. So that date pointer dot month, it's as though you did this up here, where the mouse is now resting. Up here, I have never in application code ever seen that written, ever. In all the years that I worked on C and worked this, not hundreds, thousands of times. All right. So they show you a simple example. It's pretty much the same one we looked at in 2 chapters ago on structures. But now they create today and they create date pointer. And they're saying date pointer pointing to month, pointing to day, and pointing to year. Again, if you raised your hand and said, I understand this, what are they getting out of using a pointer in this example? I think the only reason he's doing it like this is to show you the syntax. I would never do this. I don't see the value in what he's shown you right here. All right. Then he gets into, starting on 244, he starts talking about a data structure that's called a linked list. And again, you may not have any idea what this means, but I want to try to show you. All right? And since I just have Notepad open here, it's probably going to show you, but it's probably going to look even uglier than I want it to look. Okay? Imagine that we had a box here. Okay? So just we're pretending here, and I'm going to draw a box, but it's going to, like I said, it's going to look really crude. Like that, that's fine. That's not going to work very well. All right, so I'm going to do this. I'm going to put point, 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 arrow. All right. I'm showing you in this really, really bad rendition of artwork here is going to be what's called a linked list. All right? I'm just using numbers, but imagine that was information about employees. Okay, so it could be a structure. It could have all sorts of information on it. Okay? And I can't show it here because the tools are too crude. But where I've got that period, what that period is meant to be is what that does is that points to the beginning of this one. All right? So what's the problem here? Well, the problem is, okay, I want to put a new number in here, and I want these numbers to be in order. Everybody with me? I want these numbers to be in order. So the new number that I want to put in is number 41. Does all that make sense? The problem is, I want to put that in here. I guess I need a little more space here. But like I said, I want these to remain in the order that they're in. That's why I'd probably never make it in his career in as a graphic artist. So what I want to do is I want to be able to wedge that value. So instead of this pointing to over here, I want it to point to over here. Does that make sense? The problem is, the way most people do this is they go, oh, just remove this, create a new pointer, have it point down here, and then have this point over to here. The problem is, as soon as I remove this, now this can't reference anything else. It's even worse. This is now out in purgatory, and nothing can reference it. You understand what I'm saying? That's the problem with working with a linked list. So if I do this, what I have to do first is I have to come out and first I have to make a new pointer. And I have to point right away to this. That's what I have to do first. Then I have to take this pointer. Nope, I'm not even ready to do that next. Next I want to take and point and I've got to have this thing point basically up, so it's eventually is going to point over to here. See what I'm saying? Then I could take this pointer and have it point down here. So, and it doesn't sound like much. If you knew all of the applications that were out there that are set up like this, it'd blow your mind. All right? Now, the only big thing is, typically when you have the last one like this, 45, if 45 is the last one, typically that'll have in there, and you know what this means now. You're done. But sometimes people don't like that. So what they do is they take this, instead of having it \0, they have it point back again to the beginning. That's called a doubly linked list, so it points back to itself. And if that confuses you, they show you this in the book on pages 245 and 246. Now, I could have used their pictures, and they are much better, but I'm trying to show you what's happening here as you go through and do this. Creating a linked list isn't difficult. Maintaining a linked list can be a headache, for the reasons I just tried to show you with bad art. Oh, well, bad art, that's tomorrow. That's collectors of really bad art. All right? It's Corba. Yeah, there you go. I shouldn't, but so they show you on 246 and 247 how to start creating a real simple linked list. Here's the entry, and what's that? It's of type entry. So it's got the whole box with both things in it, and there's a pointer called next. And when you do this, what you're doing is pointer manipulation when you're working with a linked list to try to have it point to what you want it to point to. And if I turn up a little further here, on 249 in the book, they're showing you exactly what I tried to show you. And in much the same way, I get to go back and use my good art again. Now, what if I want to come through here, and now I've done this. Okay, everything's cool. Now I want to remove 41. They quit. I have to make sure again that before I remove it, I go and I have I take and reset 30, 34 to point to 45, then I can just poof this, right? That's what a lot of this stuff is about. That's a lot of what pointers are used for. In fact, if you look at the program on page, it starts on page 250 in the book, we're on 249, that's traversing a linked list. And what are they doing? They're traversing it completely using pointers. So what you get is it says, oh, this points to this, which points to this, which points to this. Now, the examples that they're showing are very similar to the ones I'm showing, except where I've got the box side by side, they've got it above and below, but the idea is the same. It's real easy when you show something like numbers. It's much more difficult. What you have up there, rather than being integers, is a structure. Because structures can be unbelievably complex. They can contain pointers of their own, arrays, etc. So what they show in that top box, they're not really being super showing what the real world is like, for lack of better words. All right. If that hasn't confused you, I'll continue on and see if I can. Like I said, with a lot of this, and I'm not just saying this, you got to read the book. It'll make more sense if you read the book. It really will. I'm not saying it'll, oh boy, that totally makes sense now, but it'll make more sense if you read the book. Now, what gets confusing is, if you notice in here, you can say char star const character pointer, and notice the difference between these. Is the word const here, or is it at the beginning? So notice in the first case, if the pointer is always going to be pointing, this is a character that constantly points to C. All right. Instead, it says if the location will not change, then this whole thing is constant. So you can work with the word constant here, and I'm not going to go any further than that because that gets unbelievably confusing. So why would you want to make something constant? You already know that. You know what constants are. If you want to prohibit something from happening, this is a way of doing it in this language. All right. And again, hopefully one thing that you get out of this is you say, you know, if you remember me telling you this, Java has pointers, but they're all done in the background. You're not able to manipulate them programmatically yourself. Maybe you see why Java decided to make that distinction. But Java is not nearly as powerful as C for this reason. You can do a lot of stuff, but you're somewhat limited in what you can do. All right. All right, pointers and functions. Again, you can pass a pointer into a function. You can return a pointer from a function. So notice what they're doing here. Before the call, well, they're passing it in. They're not using the ampersand like I showed you. They're just passing it in as a pointer. And they're showing you that that was its value beforehand, and then they're changing it in the function to that. And it's legal because they're working with what? With pointers. All right. This example, I think this is the one here on 11.9. That's in your book. This is a swap function. Okay? This is very similar to the type of functions that we've done in the past, but you're doing it with pointers. Again, pointers imply permanence. Could you do this without pointers? Yes. But if you want to do it without pointers, remember, how many things can you return from a function? 1 or 0, right? We want both what that is pointing to change and what that is pointing to change. So we make them pointers, we change them both, now they're both permanently changed. And they show you an example here. All right? That they want to swap -5 and 66. And using this, they were -5 and 66, now they're 66 and -5, then they change them back again. So when you want to change more than one thing and you want to change it permanently, think of passing in addresses and working with pointers. All right? The examples that are in this chapter are not exactly like the examples that I'm showing you. I'm trying to show you more, I think, from what I at least think should make more sense to you. Here, they're returning a pointer. A pointer what? A pointer to a structure of type entry, right? And they mentioned, this is in the book, it's on the top of page 257. It shows how a function can return a pointer. The program defines a function called findEntry, whose purpose is to search through a linked list and find a specified value. When it's found, the program returns a pointer. And if it's not found, it returns a blank pointer. Why would you want to have it return a pointer? Remember, because you can have it return a ton of stuff, so you can change that stuff if you want to change it too. Find that person, give them a 10% raise, and make it a permanent, permanently change their salary or their per hour or whatever it is. Now, probably the most important part of the chapter, and it's kind of stuffed away, so if you're not looking at it, you may or may not realize it. There are people that I know that try to live their lives, they're programmers, that, oh my God, these pointers are so frigging hard, I'd rather do anything else in the world. So they do everything they can to not use pointers. Okay? And can you do it? And the answer is somewhat. All right? But why would you use pointers anyway? That keyword about optimization, since the computer is working with memory addresses, it's always going to be faster than working with the values in those memory addresses. You asked about that a little bit before, Zane. This is why you use pointers. This is why C, after almost 50 years, is still such a popular language. It's one of the fastest languages that exists. So if you write an app in C and that app is real-time sensitive, C is a good language to write it in. Because not only can you manipulate pointers, you can basically, as we've already seen, make it return multiple things and make it return other stuff. All right. One of the things that you're going to learn fairly soon in for example, in PHP. PHP doesn't have pointers. But you can return multiple things in PHP from a function. But you have to shove it into an array first and return the array. Because that's one thing you're returning, an array. All right? All right, so they come up here on page 265, and they show you a program we've already looked at. Whoops, sorry. And it's how to sum all the elements in an array, but they do it using pointers. Why? Because it should run faster. That's the only reason. You might look at it and go, that's a lot harder. It's ugly. It's all sorts of stuff. Okay. Now, I want to mention something to you that you may or may not be aware of. I may have told you before. I may not have ever said it. But again, going back to this thing, forget about that for a second. If I create an array, so if I say, if I say int grades bracket 50. Okay, so this is in my program. Okay, so ... means that I've got some stuff in here. Now I call a routine that's called figure out letter grades. All right, and I pass in here grades. Does that make sense to everybody, what I just showed you? Somewhere in here there's a bunch of code where we're reading in 50 letter grades. I'm sorry, we're reading in 50 number grades. All right, between 0 and 100. We do all that checking, we do all that stuff. Then we call figure out letter grades, so we pass this. What I'm about to show you right now may or may not make sense. But if you say it does, that's almost the highlight of the chapter. All right, so I'm going to come down here. When you do this, what you're really doing is this. When you pass an array, you're passing the address to the beginning of the array. That's why anytime you use addresses, you can use pointers instead. Typically, the syntax will be a lot uglier, but it'll run faster. And you can quite often write code that's a lot shorter. Those two things do exactly the same thing. This passes the array. This passes the address of the beginning of the array. So you say, well, that's fine. It passes the address to the beginning of the array. How would you get the next one? You can literally then just basically do a plus plus. Because what you can do with pointers is you can add to them, you can subtract them, one from the other for values, and you can tell the difference between two pointers. Don't ever try to multiply or divide a pointer. Don't try to take a pointer and make it equal to a literal. Like don't say star int pointer equals 7. Don't ever do that. You're asking for your program to blow up. Yeah, but I did it and the program compiled. Good for you. It's idiotic to do that. It's not that you can't, it just makes no sense. All right? I mean, I can run into that wall to see if I can move it too, but the chances are it's not going to happen. All right? I'm going to hurt myself before I do that anyway. So again, anytime that you work with arrays, you can change them by working with pointers. All right? The last thing that's really discussed in here of any merit starts on page 273. As I told you earlier, you can point to anything, including functions. You can pass a pointer to a function. You can return a pointer to a function. Now, before you say anything, think about how fast this could make something work. Rather than calling functions, you could be working with pointers to functions, which means that rather than calling the function, you'd call the address in memory of where that function lives. It's going to run faster. Well, I'm sorry, Jeff, that really confuses the hell out of me. I'm not going to make you do something like that in one of your assignments. But the idea is you can do it. In fact, the author says in here, I want to get you the exact thing, the exact verbiage. Yeah, there it is. Next page. Two things. First of all, you might say, well, I'm not going to ever do that. Fine. But notice what it says here. C does it all the time. I'm on 274. One common application for pointers to function is to pass them as arguments to other functions. The C library does this, for example, in quicksort. Why? Because it's faster. All right? And it says another common thing is, again, kind of what you were talking about, Kelly, last week, is dispatch tables. It says you can't store functions inside of an array, but you can store pointers to functions. So you can run through the array and say, call this, then this, then this, then this, then this. All right? It's kind of like a delegation of authority when you think about it. I asked John to do something. John doesn't want to do it, so he asked Teresa. She doesn't want to do it, so she asked Mark. Eventually, we work our way through there, and we get to Zach. And Zach owes Kelly a favor, so Zach does it. We don't care. It's a bunch of indirection. This tells this, tells this. In much the same way, those could be, in an array, you could put in the names of functions. And what that means is you could tell it then call this, then call this, call this, call this, call this. All right? So pointers to memory addresses, we're just about finished with the chapter. It says, before ending the discussion, you should note the details of how they're actually implemented. Each cell of a computer's memory has an address associated with it, and they all do. And guess what? Those addresses in computer memory are constant. Does that make sense? So this constant is this address. Where stuff gets put in memory can change every time you run a program, and typically does. All right, and that's what they're showing you right here, because that's what you're working with, are addresses. All right. I thought of going over another chapter today, but I figured that this would be enough. But the only other chapter that I would go over, and I will tell you we will do it, but we'll do it at the end, is one of the last chapters in the book, and that is it's a very short chapter, but it's chapter 17, and it's the end of the chapter that talks about dynamic memory allocation. Go ahead. No, I said the address, the variables change as far as the address they're at. If I said that, I misspoke. So what I'm saying is, no, the address doesn't change. The contents of that. So in other words, we'll keep it real simple. Let's just assume there's 5 addresses. And we're keeping it simple. 1, 2, 3, 4, and 5. And you run a program. All right? And let's just say there's a single variable in there, int x. When you run the variable the first time, the address of x may be 1. If you run the program again, there's nothing to say that it hasn't changed and it's now 5. It's still the same value, but where it's housed in memory can and will change between program runs. That's what I'm saying. No, if you have this, the address of it, if this does change, it's always going to be set correctly, if that's your question. So if I do this, I got int x, then let's give it a value. So it's equal to 5. All right, then down here, if I say int star x pointer equals ampersand x, it will know if you run it the first time, oh, it's 1. If you run it the second time, it'll know it's 5. I think that's what you're asking. No. Yes. The only way that you would do something, and it wouldn't be later, but if it was in the same program, it would be like those static variables that we talked about before. All right. But other than that, when you do that, what you're doing, in my opinion, I don't know, I'd have to have somebody who's much more memory-wise than I am. But if you would do that, if you would be hard coding stuff, you're going to actually slow the program down. Because as it runs through, it's going to find the most optimal place to put it. And it's like C is one of those languages, unlike a lot of other ones. For instance, if you have a big array, it has to find contiguous memory locations. Some languages don't do that. C does. That's why when you start throwing stuff in here, it might be, if you imagine there were thousands of these, that you might be taking in a pocket where you've got something really big where you could store it. Now you can't because you've hard-coded something in there. So yeah. When you dynamically allocate memory, you use a couple functions that are called calloc and malloc. All right? And that stands for C allocate and memory allocate. They work pretty much like one another. It's at the end of Chapter 17. Like I said, I don't want to confuse anybody more than I already probably have. But again, pointers are very strong. So we're going to look at 3 or 4 pointer examples. I'm going to give you them. I'm going to give you the code. We're going to look at 3 or 4 structure examples and probably 1 or 2 character examples. That's what we're going to do on Wednesday. All right, there's no folder or anything for today. There will be one on Wednesday, and all the code will be in there. And we're just going to spend the whole period looking at these. If we look at them and we get through 5 or 6 examples and it's 4 and you're like, I'm pretty cool with this, that's fine. Then you'll get another half a period. All right, I'd rather go through some fairly complex examples with you and, to the point where you understand them, and give you homeworks that aren't even as hard as the examples I'm going to show you. All right, but my biggest worry about giving you stuff that's too hard as examples is then what you do is you take and you try to deconstruct what I've given you, and you do that for an assignment. And it's not that that's a bad thing, but it's a bad thing if you do that and you never really learn under the hood what's happening. Then it's a bad thing. All right? So that's what I'm working with right now and trying to figure out that assignment. And if for some reason you're not going to be here or whatever on Wednesday, by the end of the period on Wednesday, that'll be out there both on the P drive, under the homework folder, and under Blackboard. Has everyone in here tried, everybody in this class, have you tried to get into your virtual desktop? Is there anybody who's had any problem with your virtual desktop this semester? Some of the first semester people have. And then I found out it's because some of them have been added to the virtual desktop pool and they dropped the class. One guy dropped, added, now, added, dropped, and now was added again. So when he dropped like the second time, I had him removed, and now they had to add him again today. And he wasn't there today, but that Armando who couldn't get on the other day, he for some reason was there, but for some reason they didn't put him in my pool. They put him in someplace else. You know, Terry didn't know why. He just said, he's in the wrong pool. I didn't know we had another pool, but he was in there. You know, it's just a pool of memory that he gives for all of your virtual desktops. All right. That's all that I had.